Always a good day when I get to break out the uranium salt.
Yep, it's time for some more Styropyro. Specifically, more crazy recipes, including nuclear recipes, from the 1930s. If you haven't seen the part with the uranium crayon, please check that one out too. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's check this out.
Hey guys, it's Drake here, and I'm bringing you the next episode of the Chemical Formulary series. For the uninitiated, I found this old book in the trash, and inside are a bunch of recipes that are about 85% practical chemistry, 10% witchcraft, and the rest being some of the worst ideas our species has ever thought of.
I found this book in the trash. Let's see what happens. I can only imagine if someone found like an old nuclear power plant procedure just sitting in the trash or something like that.
I've picked out even more ridiculous recipes to test. And in fact, preparing for these experiments got me a visit by the FBI, so you know this one's gonna be good.
Wow.
Now I gotta say it, the experiments I'm about to show you are extremely dangerous, and you'd probably die if you attempted them, so please don't. And since I was nearly banned for this video series before, I'm obligated to mention that I'm literally a chemist.
It's good to know you're an expert.
I may be crazy, but I know how to do this stuff safely. So yeah, please don't try this at home. Anyway, let's continue our dive into the absurd world of 1933 chemical recipes.
So at the time this book was written in 1933, the neutron was discovered last year. Fission was not discovered yet. That wouldn't be until 1938. The concept of a nuclear chain reaction had been theorized, but again, not observed. And it was all based upon around physics, understanding of the atom, that sort of thing, than any sort of engineering. People knew about the dangers of ionizing radiation, kind of, but anything around modern radiation protection procedures, people didn't know that much.
One of the most ridiculous ideas I've ever seen. It's a recipe for a self-igniting cigarette. I guess the motivation here was, why carry a pack of smokes and a box of matches when you can just combine them into one?
There you go.
Now,
One
if the
box.
idea wasn't crazy enough, check out that ingredient list. Potassium dichromate? I mean, yeah, smoking will give you cancer too.
Yeah, even more carcinogenic than regular cigarettes. Also, what's to stop these things from igniting in the little box and then just burning up in your pocket or wherever you keep those things?
But this is just speed running it. And the burning sulfur? That's awful. Oh, this one's gonna be fun. There's actually two recipes here, where the first one isn't quite so horrible. Now, they don't say which form of carbon to use, so I used lamp black for this because I like the sparks that it makes. As for the second recipe, I mixed
like
the
the
glues with
spark.
water and then
That's
broke out the
awesome.
potassium dichromate. Now, don't be fooled. This stuff may look irresistibly delicious, but I assure you, it'll mess you up in nearly every way imaginable.
Looks like Cheeto dust, but I don't recommend licking your fingers after handling that. It's good to show that he's wearing gloves and being safe, relatively.
In fact, it typically gets a level 4 health risk in most safety data sheets, which is the highest it goes.
So, according to the EPA, level 4 means extremely hazardous. That just one exposure, not a sustained exposure, mind you, a fleeting immediate exposure, has a low but non-zero chance of causing death or serious debilitating injury. Warnings are typically keep out of reach of children and all personnel that don't know what they're doing with the substance. So, glad Styropyro mentioned that he's a chemist, he's an expert.
To make matters worse, the completed mix looks just like cheese sauce. Like seriously, I just want to put it on crackers and eat it. I can't do
Dude.
that though, because it's like deadly or whatever.
Yeah.
Anyway, here's what these glorified matches look like
Whoa.
after a few days of drying. Alright,
Those are
let's
chunky
start with the
ones.
first mix. What the heck? This mix was hard to ignite, but once it lit, it was surprisingly energetic and
Oh, those are the worst kind, the ones that don't go and then they shock you when they have, man.
shot burning embers everywhere. I probably used too much of the mix on the end of the stick in hindsight, but at least it made an awesome effect. Now to try the real cancer sticks.
Oh boy.
Huh, that felt just like a normal match. Slow-mo shows that it still managed to shoot off a few embers, but nothing like the first
Sure.
formula. This one was easier to ignite too, but of course, it comes at the cost of being incredibly toxic. Here's a recipe for a laptop stain that's based on some of my favorite chemicals.
Oh, desktop. I was thinking they didn't have laptops back then. A computer back then was someone physically computing things by hand.
Now, I thought it'd be fitting to have a 1930s-style lab setup for these experiments. And spoiler alert, I actually used it on this very desk.
Oh, there you go.
I started with this E7Q standing desk that was sent to me by my sponsor FlexiSpot. This desk is incredibly stable and built with very tight tolerances, which means I don't have to worry about it wobbling and spilling horrible chemicals everywhere when I'm working at it.
That's a perfect way to do an ad integration. Just test their product on crazy experiments from the 1930s. I like it.
It's funny, because the original coating on here is actually highly chemically resistant already, and that's due to the magic of modern polymer chemistry. I actually had to sand this off in order to get my chemical recipe to stick to the desk. The first part of the formula calls for two beautiful compounds.
Oh yeah,
Copper sulfate, which forms these bright blue crystals, and potassium permanganate.
I remember being fascinated by copper sulfate when I was a kid, just with one of those little home chemistry sets. I just was fascinated by the blue crystals. I guess that translates because as a nuclear engineer, I'm fascinated by other blue glowy things, specifically this one, made even cooler by the fact that the blue glow is caused by particles traveling faster than light, or faster than light in water.
Which makes a deep magenta solution when dissolved in water.
Oh wow. Potassium
permanganate is actually made right here in the state of Illinois. Well, it was until the factory exploded a couple months ago. Anyway, this first solution actually stained the wood a fairly dark color on its own, even before applying the second solution. The second solution looks pretty boring, but when painted on the desk, it polymerizes into a deep black color due to the formation of polyanilins. This coating actually turned out to be slightly conductive, so I figured I'd use it to make the table into an ESD-proof workstation by grounding it.
Good idea. Yeah, a lot of the desks at the nuclear power plant, the electrical shops are ESD grounded because it involves working on a lot of sensitive electronics, as the grounding prevents static buildup that could damage circuit boards or computer chips in certain devices. Not to mention reducing the risk of data loss if, say, you have your laptop there that's hooked up to whatever it is you're calibrating in the shop. Reduces the chance of electric shocks, and it also, less conductive surface would help prevent the buildup of dust. Housekeeping procedures at a nuclear power plant actually talk about that.
It turns out, trying to drill through this carbon steel frame was nearly impossible. But then again, the desk is rated to hold over 400 pounds after all. I ended up just filing a spot where I could attach a ground wire via some conductive tape. The finished table is quite the ideal workstation for me. It is in fact resistant to various forms
Wonder what he's got that's radioactive that he's going to use.
Of chemical attack, and it is quite resistant to fire as well. The coating itself lost some of its conductivity after applying the linseed oil, but the frame itself is still grounded, which helps prevent static buildup in its own right.
Okay, I can't say I've ever taken a Tesla coil when grounding everything. That's alright.
Now, I've always liked standing desks since they're better on my back, and they're easy to build stuff on. My new lab actually came with some standing desks when I bought it, but they were built by a guy that was like a foot taller than me, so they're pretty awkward for me to use. These FlexiSpot desks have motorized legs that allow me to adjust their height on the fly, which means I can find a comfortable height no matter what I'm working on.
This is one of the best ad integrations I've ever seen.
This one's silly. Why would you want to color coal? I mean, it's far from the weirdest recipe in here, but I guess it's simple enough that I should try it out anyway.
I guess you could color the coal to show that it's been treated or met with some sort of environmental compliance, but considering this is 1933, I have no idea. Coal was a lot more popular as an energy choice back then because there weren't as many alternatives as there is now. But the EPA wasn't even founded until 1970, so I'm struggling here. Maybe it's for Santa Claus. You were still naughty, but you were less naughty, so I'll give you some colorful coal instead of regular coal. Though, how toxic is it?
Thankfully, I still had some coal left over from Christmas to try this with. I had to break it up since the recipe calls for freshly cracked pieces. Now, according to the patent that this recipe is based off of, the book is wrong in what to do with these chemicals. They need to be mixed before dunking the coal in it. I'm using potassium ferrocyanide as opposed to the calcium salt here.
So he's not actually showing the procedural steps in this book on how you make it. I'm wondering how vague they were. Because right now he's just showing, like, materials lists. Maybe he'll show it in another example.
But that change shouldn't matter. Alright, time to dunk in the coal. Did it just dye it brown? Well, that's silly.
It's a color.
I guess there's a little blue in there.
See some
the
green.
patent says that the effect is better when dry, so
that may be his camera, but I see green.
I'm gonna let some pieces air out. Holy heck, look at that! That's beautiful!
Wow!
Check out those incredible iridescent colors!
I've never seen anything quite like that. They didn't, I mean, after all, they didn't have nuclear to make fun glowy thingies back then, so I guess they gotta do it with coal. Alright!
Wow, the pieces are all so different too.
That
some
is
are
beautiful.
Orange, some blue, and most every color in
I never thought I'd say that about coal, but it really is.
between. That's amazing! For such a simple procedure, this is one of the most impressive recipes I've tried yet, and the chemistry here is fascinating as well. It's a synthesis of a Prussian blue pigment that uses the coal surface as a reducing agent.
So really, Prussian blue. You can actually use that to treat radiation exposure. Now, nothing stops you from receiving the dose, but if you happen to ingest cesium-137, which is a particularly nasty beta source, it stays in you, it has a half-life of 30 years, and can cause all sorts of nasty internal contamination. Now what the Prussian blue does is it's taken orally, goes through your digestive system, and it binds to the cesium-137 or other similar radioisotope in the intestines and prevents it from reaching the bloodstream, which allows the radioisotopes to be excreted through your stool, limiting the overall effect, so it's not like it's going to stay in your body for an extended period of time. You're still going to get dose, but it's just going to be the dose that it receives as it's emitting when it goes through your digestive system. So particularly effective at getting rid of internal radioisotopes that you somehow ingested.
The reason you get so many more colors than blue is mostly just due to thin film interference. If I treat the coal for a while, the coating ends up thick enough to look more like the classic dye. This is such a perfect example of how chemistry is literally magic. The science checks out, of course.
It is. I mean, it's the science of changing materials into other materials. And nuclear engineering is that, but on an even smaller scale when you're looking at the individual nuclei rather than the atoms or the molecules. Though there's certainly plenty of overlap.
But the fact that a couple simple chemicals transform some lumps of coal into something like this is astonishing. It's reactions like this that remind us that chemistry arose out of alchemy. What a cool recipe.
Yep, forget turning it into gold, turning it into a bunch of fun glowy things.
Here's a great recipe for removing annoying anthills in the yard. Simply toss enough cyanide in them to kill 100 people.
Deadly poison, do not allow contact with broken skin or cuts. I mean, pesticide's pesticide. This one works on people too.
Now if you think this seems a bit excessive, it isn't even the worst ant removal recipe in the series, because at least it goes away after some time. And going through this book, there are ant poison recipes using arsenic, lead, even thallium.
I like how they abbreviated powder.
Which is just a straight up horrible poison that doesn't just go away.
I'm looking at this grocery set. Water, sugar, thallium sulfate, and then honey. One of these is not like the others.
Here's a recipe for artificial fog. Now when I think of artificial fog, I think of a club filled with fun music and fog machines. But judging by the chemicals used here, this looks closer to a war crime. I mean, seriously, carbon tetra...
Infusorial earth? What? Apparently that's what they called diatomaceous earth back in 1933. Okay.
Chloride? That stuff is straight up cancer juice. And the zinc chloride product? Ugh, this is a horrible recipe. I'm looking forward to
They like
testing this
zinc
one.
too.
If you ignore the toxicity, this formula is quite interesting.
If you ignore the toxicity. Alright.
Half of it is carbon tetrachloride, which before we figured out it destroys the ozone layer in your liver, we used it widely as a fire
They
extinguisher.
even know about the ozone. What did they even know about the ozone layer back in 1933? I don't know.
And here, this formula actually burns it as the oxidizer, liberating carbon and zinc chloride in a pyrochemical single replacement reaction akin to a thermite. Something tells me that a recipe that's half fire extinguisher will be hard to ignite, so I'll be using these ancient sparklers to ignite it. Ugh, here we go. Alright, any minute now. This stuff seems slow to start, but I think it's picking up pace now. Oh
There's
wow, it's
fog.
really billowing out fog now. That's some of the thickest smoke I've ever seen made by a pyro device. That's actually extremely impressive. You know,
dense.
this mix is both clever and stupid at the same time. The product of this reaction is zinc chloride smoke, which has a potent affinity for water. This means those particles bind to water in the air, which increases the particle size and thus makes the smoke even thicker. Now that smoke is also quite acidic,
Yeah.
and it's full of zinc, so it's not great to inhale.
So wonder what direction his neighbors live. Yeah.
However, a very similar mix called HC is still used today by military and police as a smokescreen. In fact, if you go to the war gases section of this book, they'll tell you that I'm overreacting and that mixes like this are harmless.
I like that there's a section for that. You gotta at least give them that. There's a section they've put in for those type of chemicals.
Now, I can't say I agree, but I guess it's nothing compared to these other crimes against humanity. Have you ever needed liters of sweat, but didn't want to go through the effort of making it naturally? Well, lucky for you, here's a nice recipe for artificial perspiration.
I guess for scenes in movies where they didn't want to bother having the actors get all warmed up and ready for the scene. I don't get it.
I love how there's recipes for both new and old sweat here. How lovely. Let's mix some
Oh, that's what they mean by fresh. I wasn't sure about that.
of this stuff up. I can't help but wonder what the original application of this would be, but without any context given by the book, I guess it leaves it up to our imagination. I will say that the use of lactic acid and ammonium carbonate means that this would probably make a decent mosquito bait in traps.
Yeah.
Well, here's 2 liters of artificial sweat. Now, does it smell like sweat? I can't really say that one does. Let's try the,
Or does one have a distinct old man smell and the other one doesn't?
try the old one. Oh yeah, that one actually does smell a bit like sweat. Huh. How does it taste like sweat?
Oh boy. There you go.
Oh yeah, it actually does. It
The whole sticking your finger in there, I mean, he at least knows what it is.
tastes a little bit like sweat. Interesting. I don't know what it is with this book and inhaling chloroform and ether, but here's another brilliant concoction
They use ether for everything back then.
to inhale while you're sick.
Tincture of iodine. Wow.
Now seriously,
Spirit of
what's this
ether.
even supposed to do? Kill germs or put you in a coma? Now those other ingredients are no cakewalk either. Phenol and creosote? Jeez. Smoke pot. Oh, it's a smoke pot. I'm guessing it makes a big cloud of smoke for use in theatrical effects.
Has arsenic.
Now there are 2 recipes here, so you can pick your poison. Do you want to inhale burning arsenic or sulfur?
Literally pick your poison. I like that.
If you're concerned about the amount of arsenic in that second formula, the good news is that red arsenic is only 70% arsenic by weight, so it's not quite a full pound of arsenic there. It is,
Only 70% of a pound of arsenic.
however, a pound of ass. Now even a pound of ass has enough arsenic to kill like 500 people,
awesome.
so I decided to go with the burning brimstone version. Besides,
Spontaneously
sulfur is an
combustible.
underappreciated element anyway. Yeah, it's smelly, but it can take on beautiful forms, and it has several critical roles in biology. Plus, when it comes to fireworks, it's the great balancer because it's happy being either the fuel or the oxidizer. There is another issue with this mix though, and that's that it doesn't even work. I can't get it to light on fire, which is a rarity for me.
Look how
If you've
close
ever
he's
had the
getting.
urge to plate random stuff in metal, then this is the recipe for you. Apparently with just 2 ingredients, plastic and even bone can be plated in pure silver. Now I don't know about you, but bone silvering juice just sounds magical, so I'm gonna test this one out. I found this deer skull while hiking with my cats recently that'll be perfect for this experiment. Thankfully,
Okay.
the bugs had already picked out all the gross stuff, so it just needed a quick rinse with water followed by a light wash with naphtha. I didn't have enough canola to make gallons of 4% solution, so I just made what I could and rinsed the skull with it several times to make sure it soaked some of that up. Now the book doesn't say what concentration of silver nitrate to use, so I went with 4% like the canola and poured it onto the skull. The resultant plating was fairly dark, but a quick polish with a rag really shined it up. I think the result is quite impressive. The smooth parts of the bone ended up with the shiniest plating, whereas the more porous areas kept a darker
That's
tone.
cool.
Now it's hard to capture on camera, but some areas are covered in little crystals of pure silver. A beautiful skull and a beautiful desk to boot. How lovely. You might think that the ink section in here would be pretty boring, but it turns out there are plenty of exciting recipes in here. Now this one claims that it can etch glass, which is pretty crazy considering how
I like
resistant
that it specifies using a wooden spatula. That's good.
glass is to most chemicals. Now notice how they tell you to not get it on skin. If this book tells you that, they mean it. Hydrofluoric acid is a funny chemical. It's only a weak acid, yet it can dissolve glass, which is something that most strong acids can't do. The recipe calls for lead and wooden
That is
utensils,
interesting, isn't it?
but I subbed them out for modern plastic since they're even more resistant to attack from HF. So what would happen if I spilled this on my skin? Well, I probably wouldn't feel anything at first, but soon it would reveal itself as the ultimate bone-hurting juice. Hydrofluoric acid quickly penetrates skin to attack bones and liquefy flesh, and exposing just a few % of your skin to it can be fatal. This is what makes this ink one of the most dangerous recipes in the whole series.
You know, with ink like that, talk about the pen is mightier than the sword.
On the flip side, the ink did a great job at etching the glass, although it did bubble up a bit and cause etching in unintended places. This etched glass gives really cool effects with laser beams, as it preferentially illuminates the etched part. This is certainly a cool recipe, but I'll say, it is quite scary to work with.
Sure.
This one is so bad. Eat 3 grams of a mercury salt for stomach gas? And this would straight up poison you.
I mean, it'll give you relief in that you're not gonna experience stomach gas for much longer.
Whatever mercury you'd absorb would stay with you for life. And you know what? Your poop after this would be so toxic, you'd need a hazmat team to clean it up. I have no idea how people survived it all back then. Judging by these parade torch
Must not have had much stomach gas back then.
The 1930s really knew how to throw a parade. Look at that first formula. It contains Paris green, which is an arsenic salt, and calomel, which is a mercury salt.
Wow.
As you can imagine, inhaling the fumes from that would be horrible, but maybe the beautiful blue flames would be worth it. Now that second formula there is only mildly toxic, so I think that's the one I'm going to test. I'm going to assume that copper ammonium sulfate is an old name for the complex tetramine copper 2 sulfate monohydrate. Now I don't have any of this on hand, so I had to make some by reacting a copper sulfate solution with ammonia.
Look at that color.
The resultant product is an incredible deep blue color. Once this dried,
purple.
I used some to make a batch of this blue parade torch mix and filled some tubes with it. What could possibly go wrong?
Toxic fireworks.
It sounds pretty cool, but the color is really washed out. I can't say I'm very impressed with this one. I still had some copper complex left over, so I figured I'd try to improve the mix, using an ammonium oxidizer and a hexamin fuel. Here we go!
Whoa, that one's cool.
Okay, now we're talking. Wow, that sounds like a rocket! And geez, that's an eye-searing amount of blue light. Yeah, my camera hates that. I should note that making a good blue and
I appreciate me some blue glow.
fireworks is quite the challenge. Well, at least when you can't use arsenic and mercury. But I think this formula is an exception. It just needed some adjustments to keep the flame temperature down. This one looks really useful. It's a simple method of plugging holes in metal. It uses just 2 ingredients.
Sure.
What could possibly go wrong? I've accidentally poked a hole in one of my favorite microwaves here. And since I don't want the microwaves to escape
How many
or
microwaves
anything,
does it go
this
through?
is a perfect opportunity to test this recipe. I have to say, these ingredients are quite unusual, but at least they're easy to mix up. I sanded off some of the coating there to expose the bare metal. Let's go ahead and pour some of that mix on there. Alright, time to heat it up. Is it supposed to catch on fire like that?
Did it make a bigger
Wow,
one?
that mix burns quite hot. Let's take a look at what's left.
Well, it plugged a hole.
It definitely plugged the hole there. This stuff is hard as a rock. Impressive. So what happens if you spill water on it? Oh, look at that. It reacts with water. I guess any holes you plug with this won't be watertight. It would also kill you in seconds if you did this indoors. Yeah, that's right. Those little bubbles are what make this the deadliest recipe I found in the whole book series. The recipe makes a
I
little...
like how he said that after the fact. What we're not seeing is I'm sure he's wearing all sorts of PPE, respiratory, goggles, face shields, while he's doing all these things.
Aluminum sulfide, which generates the extremely deadly hydrogen sulfide gas on contact with water. If this gas builds up to a measly 1/10 of 1% in air and you take a single breath, you'll get knocked out almost instantly, and your unconscious body will quickly inhale a fatal dose. I cannot overstate how dangerous this recipe is. The ingredients are fairly benign, so an unsuspecting user would likely be oblivious to the demon they're creating by mixing this. Ointments aren't typically something I consider exciting, but here's an excellent exception. It's a mercury-based ointment that also uses
I think that includes cholesterol.
nitric
Straight up
acid as a
cholesterol.
bonus. Now what you'd use this horrible potion for, I have no idea. But whatever it is, it must be terrifying to justify using these ingredients. Ever want to trick your geologist friends into thinking you have something special? If so, look no further than this simple recipe. Simply mix uranium salts with a powerful oxidizer, and then cook the daylights out of it. What a brilliant idea. It's always a good day when I get to break out the uranium salts.
Yep.
It's hard to deny their beauty, and this recipe makes use of their strong fluorescence. Of course, using uranium to make fake rocks is a bit silly, because unsurprisingly, this gives a product that's radioactive and very toxic.
It is radioactive, though the main hazard would be if you ingest it, because you're stacking its radiotoxicity with its regular chemical toxicity as well. Though compared to other stuff that Styropyro's shown on this video alone, wouldn't even put it in the top 5 as most dangerous substance.
The uranium is diluted with sodium nitrate here, and although this compound isn't very toxic, it brings up its own set of issues, one of which is that it's a powerful oxidizer. Anyway, let's cook this uranium mix.
Cook some uranium.
This could be a bit faster, couldn't it? Oh yeah, there's some brown gas being released. I think that's some of the uranyl nitrate breaking down there. You don't want to breathe that.
Don't eat uranium, don't huff uranium.
Alright, I think that's good enough. Here's the completed fake mineral. It is quite sparkly, and it turned redder than I expected, probably due to trapped nitrogen dioxide gas.
It just looks like a frozen smoothie.
But is it actually fluorescent? I'll take that as a yes. Is this recipe worth it? No, not even in the slightest. It turns out, both of these ingredients here are deliquescent, which means they have such an affinity for water that they'll turn themselves into a puddle on a humid day. That means you'll get radioactive salt everywhere, and simply touching it with your bare hand will leave uranium on your skin.
Seeing anything involving uranium and liquefying it, powdering it, no, because it's just like handling anything else that's hazardous. But if this was done at a lab or at a nuclear power plant, well, then you have to comply with radiological waste categories on everything it spills on. So all of that becomes radioactive waste and has to be put into the radioactive waste bin, processed, sorted, and it can get very annoying, messy, expensive for something that really doesn't need to be.
Besides, there are plenty of real fluorescent minerals out there that are cheap. And if you're going to go with something artificial, you might as well pick something that nature can't offer. For example, I have this neat gag crystal here that's not only fluorescent, but it's also phosphorescent.
Oh, that's funny. I didn't realize that's what it stood for.
It's ferromagnetic too. Most importantly, it won't give you uranium poisoning by touching it.
Or inhaling it, for that matter.
What a silly formula. Chemicals that glow in the dark? Well, that sounds like fun. I mean, nowadays we're spoiled with all sorts of phosphorescent pigments, so I'm curious to see how an old recipe like this holds up. For this recipe, I have to make some modifications to use what I have on hand. I don't have zinc sulfide, but I do have zinc and sulfur, which when burned produces zinc sulfide along with a bunch of heat. My hope is that this short combustion reaction will be enough to produce at least some amount of glow powder. Well, here goes nothing.
Set something on fire with the laser.
Oh wow, that's a lot of fire. I love the green flames there from the zinc metal burning. Those fumes are delicious.
Dude.
Yeah, that crucible didn't like that one bit. That must be incredibly hot.
Wow.
Here's what the finished product looks like. When I hit it with a UV flashlight, it actually gives a decent afterglow.
Oh, that's
Sure,
cool.
It's nothing compared to modern pigments, but this stuff works surprisingly well considering its simplicity.
Uranium does get its characteristic green glow from UV light. By itself, it doesn't do that, but as you can see, a lot of things can have some funny glows when you apply UV light to it.
I've picked out some of the better chunks to hit with a UV laser. Check out that afterglow.
Oh, that's cool.
I can't believe how well this works given the modifications I made. There are plenty of toilet fluids in this book series. The toilet milk in my last video turned out to be really popular, so I feel like this toilet vinegar is worth trying as well.
Toilet vinegar, okay.
This recipe calls for glacial acetic acid, which is basically ultra vinegar since it's 20 times more concentrated than normal vinegar. The silly thing is that the recipe dilutes it to regular vinegar strength with water, so it really doesn't need the glacial stuff here. Well, I still don't know what this stuff actually does.
Look at that toilet.
So I guess I'll just feed it to my favorite toilet. Oh, you know what? This is a perfect opportunity for a baking soda volcano. Oh wow, what a beautiful ad-friendly chemical reaction. So many bubbles.
That's super tame compared to everything else. I love the combination of it being crazy, but at the same time, he clearly knows what he's doing. Thanks again for the recommendation, and thank you very much for watching. I'll see you next time.